In this project, we're going to use Visual Code Studio for building our full stack NFT marketplace. So let me tell you what I have done so far in this project. So all I have done, I have created an empty folder, NFT Marketplace Smart Contract, and this is the second video of our complete project. In this, we're going to build the smart contract for our NFT marketplace. In the first video, I gave you the complete overview that what we're going to build in the next 20 hours. We're going to build the smart contract. We're going to build the front end application and the back end. So this is the second video. In this, we're going to build the smart contract for our NFT marketplace. So if you haven't watched the first video, watch, you will have a better idea. You will see that what we are exactly building. Okay, in this, we're going to build the complete smart contract for our NFT marketplace. So let's get started. So before we get started, I just want to remind you that all the assets, all the starter file, all the complete files are already provided to you. So simply open a new tab, type Daulat Hussain, click on the very first link. You will come to my website. Here you will find everything about me. Then go to the blog section, hit the very first article. So this is the article in which you will find all the starter files. So for the starter file, navigation, footer, all that's are divided in section wise. So you can, if you stuck anywhere, you can simply download the file and compare your code. Okay, so with that said, now let's start working on our smart contract. So open up your terminal, type CLS to clear your terminal, and now we have to initialize the npm. Okay, so type npm init, and we have to give the name to our npm package, the project name we have to call it. So let's call it NFT Marketplace. Hit enter. Now you can give the description to your project. I'll call it NFT Marketplace. Then you can give your name as an author. I'll give my Daulat Hussain. And just clear the terminal. And here you can see we have successfully initialized our project. And if you go to this package.json file, this will contain all the information about the project, that what are the npm packages we are using, the name, the version, the descriptions, and the scripts. So all the data you will find about your project right in this file. Okay, let's open your terminal, and now we have to initialize Hardhat, because that's the tool we're going to use for building our smart contract and testing. Okay, so simply initialize that. So if you haven't installed Hardhat in your computer, so the very first thing you have to do is to open up your browser, type Hardhat, go to this installation documentation. From there you have to copy this line and simply come and in your terminal and paste and install the package. So once you successfully install, then we have to initialize that. So simply type npx Hardhat init, and now this will initialize the Hardhat. Now click on enter, enter, and enter. So here we have initialized the package, and now we have to install this recommended npm package by Hardhat. Okay, so simply copy this npm install and paste here and install. This process will take a little bit time, so just wait. So we have successfully initialized Hardhat in our project, and on the right hand side you can see that Hardhat created couple of files and couple of folders. So the first folder is the contract, we have the script folder, we have the test folder, we have the git ignore file, Hardhat, package.json, and readme file. So all these files are created by Hardhat. Okay, so let's clear the terminal and come to this contract. Inside that you will have a demo contract by the name Lock Soul. If you open that, here you will have a demo contract, so you can have a look that how they have written the smart contract. But we're going to create our own smart contract file. Okay, so simply copy this one, and we need to delete this lock contract file, and now we have to create our own. So I'll call it NFT Marketplace.soul. So this is the name we're going to give to our smart contract file. Okay, this is the file in which we're going to write the smart contract, and this is the node module. In this, all the packages which you will install and use in your project, that's all you will find inside this, which you don't need to worry about it. Okay, because we're not going to use in this any of these. So, and here you have the another folder script. In that script you will have this file deploy.js, and inside that you will have this pre-written code which allow us to deploy our smart contract. Okay, so here we're going to do a little bit modification. Okay, so first thing I want to do is to remove all this extra code, all these comments. Okay, and I want to remove these code as well. You can keep it or you can remove it, it's totally up to you, but I don't want to add any extra information in our smart contract. So I will simply select this and I will delete this one. Okay, I'm going to remove this because we are not passing any information in our smart contract, in our constructor. We are passing anything like that, then definitely we're going to add those. But for the time being, let's remove it. And let's remove this comment as well. So we should start with a clean environment. So this is our deploy script, which allow us to deploy our smart contract. So let's close this one and close. And inside this test, so we had a demo contract in our contract file, and that's the test is written. So if you want to test your smart contract in your terminal, you can do it using Hardhat, okay? Or if you are using Ganache, then you can do that as well, okay? But I'm not going to do the testing using Hardhat, okay? So we just leave this file as it is, okay? So you can have a look at how you can test, okay? This is not a fancy, it's a very simple code, and you can use all these function to test the contract. So let's close this one. And here we have the get ignored. So here we are ignoring couple of files. So we don't want to push this data to GitHub. So ultimately, once we build this project, we're going to push this project to the GitHub. And here I have defined that I don't want to push my .env file, which we don't have in this project. We don't want to push the node module. So all the files which we don't want to push to GitHub, that's all we'll define here, okay? And this is the Hardhat config file. Here we're going to do the configurations for the network. Okay, so let's close this for time being. And here we have this package.json file, and here you can see here we have the package.json file which contain all the information about the project. So recently we have installed the Hardhat package, recommended package, that Hardhat toolbox, and you can able to find here. You can see that we have the Hardhat install. So everything's working fine for this. Here it is the readme file, and now we have to install one of the most important package which allow us to create NFT and build our smart contract, that is OpenZepline. So OpenZepline is a very powerful tool which you can use it to build any kind of smart contract. So we're going to inherit some of the property from OpenZepline for creating NFT Marketplace, okay, contract. So to do that, let's come here. I'm here on npm.js. So make sure you type simply npm.js and you will come to this article, and you can simply copy this npm install OpenZepline contract, okay? Select this one and copy, come back and simply install that. Just wait. So here the installation is completed, and if you come to this package.json file, here you will find the information about this. So here we have installed that OpenZepline 4.7.3 version, okay? You make sure you should always use the latest version. So this is the, close this one. Now let's come back to our NFT Marketplace contract file. So now we're going to build the smart contract for our NFT Marketplace, because we have done all the general setting. We have installed all the packages which we need to build the smart contract. So I hope all these things are making sense. And now we are going to write the smart contract for our NFT Marketplace, okay? So first thing we have to do is to provide this license identifier, which is spdx license identifier, and I'll call it MIT. You can call it unlicensed, it's totally up to you, but I will call it MIT. Now I have to define the version, Solidity version, so I'll pick that 0.8.4. So that's the general convention we have to follow whenever we want to write our smart contract. Now I'm going to import the OpenZepline contract, which we're going to use in this project, okay? So we're going to call some internal import. Let me give this comment, and I'll NFT from OpenZepline, and I will simply paste this, okay? So once you install OpenZepline smart contract, all these packages will get installed into your node modules, and from there we are getting this, okay? So the first one we have is this, all these packages. First one we have this contract. Inside the contract we have this utils, and then we have this counter. So this counter will allow us to keep the track that how many items are getting created, how many items are getting, NFTs are getting sold, how many users are creating that NFT. So it will allow us to keep the track of the number of token, okay? So if you click on this, you will come here, and here you can able to find that what we are exactly using from this contract. So as you can see, this is the contract we have. In that we have these three functions. So here we have these three functions. The first one is the current one, which will give you the current ID okay, when you will call this function. And now we have the second function, which is the increment. Its work is to increment the number, okay. And the third one we have is this decrement function, so this will decrement the number, okay. So these are the three functions we are inheriting from this counter contract. So let's simply close this one, and here you can see, here we have the token contract, and here we are importing the token contract. So inside the token contract we have this ERC21, and we have using this extension version. Click on this, and here you will find the contract. So in this contract we are inheriting some of the property from ERC 7021, okay. And you can able to find that what exactly happening, okay. You can see all this. Now here we are, simply click on this, and here you will find, so what are the things we are using in this. So that's all information you can able to find about each of these packages, okay. You have two options. Either you can use this packages to build your smart contract, or you can write the entire code from scratch. But I would never recommend you to go with scratch, because once you do that you have to do the testings, and the packages which we are getting from OpenZepplin, it is well tested, and a lot of companies are using these packages to build the NFTs, okay. So you should always follow those code which are already exist and which is already tested by various company, okay. So that's why I'm taking this approach, okay. So these are the three imports we have to do. Now I want to do one more import. We import the Hardhat console because we want to check the value in our console. So these are the four import we are doing, and now let's start writing our smart contract. So I'll call it contract, and we're going to give the name to our contract as NFT Marketplace, and we're going to inherit some of the property from ERC 721, okay. And now we're going to use the counter. So for using that we have to say using counter for counter. So this is how we can use the contract of counter, okay. So we have the counter, and now we have to take the variable. So first is going to be the counter, and we'll call it private, and it's called be token ID, because every NFT will have a unique ID, okay. On the base of that we're going to identify the owner and the selling properties, okay. So token ID, and we'll take another variable, counter private tokens sold. So this will keep the track that how many tokens are getting sold, okay. So these are the two variables we have, and now we have to take the address, payable, owner. So when we deploy the smart contract, so whoever will deploy the smart contract became the owner of this contract, NFT Marketplace, okay. And we are making this payable so it can receive funds now. So this is the payable. Now we have to create the mapping, and that we're going to do with UNT, okay. And we'll call it market item, and this will become private, and I call it ID market items. So let me tell you what is happening here. So every NFT will have a unique ID, and we will pass that ID in this mapping, and this is market item is the struct we're going to create, which will have all the details about that particular NFT, like the owner of the contract, the seller of the contract, the ID, the balance, the sell property, okay. So just imagine that this ID is unique to NFT. So when you will call this ID, it will give you the details about that particular NFT, okay. So this is how we are mapping. Now let's define the struct. So we'll call it market item, because that what we have defined in the market item in the mapping. So call it market item, and we have to define that. So first is going to be UNT token ID. The second one is going to be the address, payable, and the seller, so the one who will create the NFT, and again address, payable, and this will call owner, UNT, and this will be the price of the NFT. And now we have to keep the status track, okay, whether the NFT is sold or it's unsold. So this is our struct. Let's come down, and now we have to trigger the event. So whenever any kind of transaction happens, whether it's buying or selling, we have to trigger that event, okay. And I'm not coming up with this function because this is the standard we have to follow for building an NFT smart contract for a marketplace. Okay, so these are the standards which is defined in the OpenZepplin smart contract. You can have a look from there. Okay, so we're going to define that. I'll call it market item created. Okay, now in this we're going to pass the exact thing we have passed in the struct. So first thing is going to be UNT index and token ID. Second, then one is going to be the address seller. Third one is going to be the address owner. Then UNT is going to be a price, and the last one is going to be the boolean is going to be sold. Okay, so these are the events. Why I'm getting this error? Let's provide this comma. Still I'm getting error. Okay, let's remove this one. So let's save it, and right now still we have the error. Okay, let's continue working. So let's call it constructor, and we're not going to pass anything in this constructor, but we're going to use this ERC like 721, and in this we're going to define the symbol of our NFT. All the NFT will create it. We have to assign the symbol and a name. Okay, so the name I will call it NFT metaverse, let's call it token. Okay, and the symbol I will provide is my NFT. So this is the name and the symbol I'm assigning to my NFT smart contract. Okay, and let's provide this bracket. You might be thinking from where I'm getting this. Okay, so if you come here we have this inheriting this. If you click on this, you can come here, and here you can see, let's scroll down. Here we are passing that in the constructor. So we are passing the name and we are passing the symbol in that ERC 721. Okay, so that's what we are passing here. So once you pass this, the rest will take care by the OpenZepplin. Okay, so we have to use this property. Let's come back. Okay, these are the name, these are the symbols. Now we'll take the owner is gonna be the message payable message dot sender. Okay, so whoever will deploy the smart contract become the owner, and we are using this payable so it can receive funds. So this is our constructor. That's the only thing we want to do, and as you can see we have no longer having that error because we haven't used the constructor. That's why we had got that error, but now the error is gone. So keep working on it. Now we'll take a creative function, and this will call update listing price. Okay, and the reason why I want to create this function, because as a owner of the marketplace I want to charge money. So those who will create NFT, they have to pay certain amount to me as a owner of the marketplace. Okay, and this function will allow me to update the price which I will define in my smart contract initial price, and if I want to charge higher, so this function will allow me to change the price higher or less. Okay, so this is the function for that. So it's gonna be a UNT. It will take the UNT and we'll call it listing price, and it's gonna be a public payable because the price will change. So we have to define a modifier because I want that this function should be only called by the owner of the smart contract. No other person can call this function. Okay, so if we leave this function like this, so anybody can update the pricing, listing pricing of our smart contract, but I want that only owner can update the pricing of this listing. Okay, so we have to create a modifier for that. So let's come up here and I'll call it modifier and only owner, and here we have to set the condition for that. Okay, so we're going to check that owner message.sender, that whoever is calling this function, it should be equal to owner. If someone else call this function, we have to say only owner of the contract or marketplace can change the listing price. Okay, so this is the modifier we are using. Simply come here, and now we have to give this dash and this means that once this modifier get success, means it's true, then the other function will keep continue. Okay, so this is how you have to continue code. Now what you have to do, simply copy this only owner, and here we have to pass. So in this way we can easily able to call the modifier whenever someone will call this function. And now we're going to do the changes here. Okay, So we are receiving that listing price. So let's call it listing price, but actually we haven't defined that listing price in our state variables. Okay, so let's come up here, and here we're going to define that listing price. So let's come down, let's call it, take a unt, and we'll call it listing price. And initially we want to charge something like 0.25. Okay, so this is the amount we want to charge, and now we have to update this with the functions. Why I'm getting this error? Okay, we are getting, so here we have to define that whether we are charging the fee in terms of way, ether, write that. So we're going to say that we are charging ether. Okay, so here we have that listing price. So let's decrease to 15. Okay, now it's good. So here we have the modifier. Let's close all this one, close this one as well, and close this one as well. Close this struct. Now let's come down, and now we have to write a function which allow us to fetch the listing price, so anybody can check that what's the amount they have to pay for creating NFT. Okay, so we'll call it function, and I call it get listing price, and it's gonna be a public, so anybody can call this function. View returns unt, we have to return the unt, and then we're going to return the simply listing price. So listing price. Okay, so if you're new to Solidity, so here what I'm doing, I'm making this function public so anybody can call it, and I'm using this view keyword. You can use it pure or view, but why we have to use view? Because we are reading the state variable. So listing price is a state variable, so if we want to read that variable, then we have to use the view, and we are using the return keyword which allows us to return any value. Okay, and here we have returning that. So that's our get listing price. Now let's come down. Now let me give this comment where I call it let create NFT token function. Now we're going to start actually working on our NFT smart contract function. Now let's come down, let's call it function, and I call it create token. So with this function we try to create a token and assign to a particular NFT. So this is how we can track and do the mapping. Okay, so that token is going to be, let's say, string, and in that we have to pass the token URI. So the token URI is actually the URL of the NFT. So when someone will upload that NFT, we will get the URL of that NFT, and that's going to have a specific ID. Okay, so that's what I'm doing here. So simply remove this, and it will also take the price. So how much price setting by the NFT creators. So unt and price, it will come public, payable, and we have to return this one, and the thing we want to return is the unt, and unt is going to be the basically the ID of this token. Okay, so here we have to do a couple of things. So as you can see, we are doing this normal thing. We are taking the URL of the NFT, we are getting the price, and we are returning the token ID. Okay, now here we're going to call the token ID, and we'll call it increment. So whenever someone will create NFT, this token ID will get increase. Okay, and now we have to use this one. Okay, it will get increase. Now we'll take another unt, and I call it new token ID, and this is coming from token dot increment current. Sorry, so first we are incrementing the token ID, and then we are getting that current token ID, and that current token ID we are assigning to this new token ID, which is going to be assigned to the NFT. Okay, now let's come down, and we'll call this min function. In that we're going to pass this to message.sender, and we have to pass this new token ID. Okay, and again we are using this min function from OpenZepplin. Okay, so to see what's in there, all you have to do is to click on this, and you will land here, and here you can able to find the function that what exactly happening here. Inside that we are passing this to address and token ID. It's an internal function, and here we are doing two check. First, the address who's deploying this NFT, it's not any contract, it has to be the address, user address. Okay, and the second check we are doing and passing, the second check we are doing that whether this ID is already exist or not. Okay, so that's the two check we are doing, and then we are updating the entire state. Okay, we are doing this transfer. Once again, I tell you that you don't need to remember all of these things. All you have to do is to simply use this function, and if you want to become an expert, then definitely you can check the source code, okay, to take the reference, to take the idea. Now let's continue working. Now we're going to call one more function. We'll call it set token URI, and that we have to pass this new token ID, and simply in this we have to pass this token URI, the image URL. Simply remove this one and close this one. Again, we are getting this function from the OpenZepplin and we are using it, okay. Here we are from getting here from here and receiving it. Now let's come here, and now we have to create one more function like create market an item, and in this we're going to pass the two things. So first thing, we'll pass the new token ID and the price, and this function is not coming from OpenZepplin. We're going to create this function, and in that we're going to pass this two data, token ID and the price, okay. So this function is not there, we have to create, okay. And now once everything's got successful, we have to return the token ID, new token ID, okay. Simply copy that and simply come here, and now we have to create this function. So we'll call it create market items. So first function will create the token ID for that particular NFT, and this function will create the token market items, actually the NFT, and it will assign the data, all the data, to that particular NFT, okay. In this we're going to receive the two data which we have passed. So let me give this comment like creating market item, okay. In this I'm going to pass this two data. So first is going to be UNT, and it's going to be, let's say, remove it, and let's call it token URI, let's token ID, and the second one is going to be the price itself for the token. So let's call it price. It's gonna be let's say private functions, because we're going to call this internally, not externally, okay. So that's the two data we are passing here, receiving, and here we have to do a couple of check. So first check we'll do that price should be greater than 0. If it's less than that, then we have to display this error message, price must be at least 1. We have to do the other check, and here we're going to check that message.sender value should be equal to listing prices, because we have to get our commission. So they have to at least set the price to the listing price, okay. And if it's less than that, then we have to display this error message, price must be equal to listing price. So this is the two condition we are checking. If it passes, then we can continue with the work. Let's come up here, and so here we have the mapping. Each NFT will have a unique ID, and all these NFTs are stored inside this ID market item, okay. We're going to use this and pass the ID to find the NFT and the entire data, okay. So that's the entire logic. So simply copy this, and we're going to simply pass the token ID, because this is how we can identify that which item is getting created. It's going to be market. We have to call the struct, and here we have to update the entire data, okay. We are assigning a unique ID to that NFT, and then we are calling the struct and updating the data. So first is going to be the token ID, because one NFT can have one unique ID. The other one is going to be the payable, and it will going to be a message.sender, and we have to say payable address this, okay. And this address, this means that the NFT or the money belong to the contract itself. Message.sender is the one who will call this function. It could be anybody who try to create the NFT, but address, this means the smart contract, okay. So payable, now we have to get the price, and we have to set the false. So currently the NFT is not sold, so we have to set the status to false. So that's why we are setting false, and here we have to give the comma, and now we have to call this transfer functions. So we want to transfer the function, sorry, we want to transfer the NFT from the message.sender, the one who creating the NFT, to the contract, and here we call address this, and we have to pass this token ID, okay, token ID. So this is the transfer functions. Why we are getting this error, just wait, remove this one, and now we don't have the error. So let me tell you what happening once again. Here we are taking the ID market item which contain all the NFTs, and that we are assigning this token ID, and that token ID contains the information about the entire data of that NFT. Token ID, message.sender, contract address, price, and the false status. Okay, and then we are transferring the token from the owner to the contract with an ID. Okay, and again this transfer function it's coming from the simply OpenZepline. And now we have to call this event, okay, because we have created an event, and whenever the transfer of tokens happen, we have to call this event. So we'll call it market item created, and here we have to fill out all these details. So make sure you have to fill the data in the same order which you have defined in the event. Okay, so when you call the event, it's called emit, then you give the name of that event, whatever you have defined, and all the parameter you have set that in the event, make sure you should assign the value in the same order. That's the thing you have to keep in mind, otherwise it will give you an error. So let's come here. Here you can see, here we have given the name ID market item to our event, and this is how we are calling it. Here we're going to do the changes. We'll call message.sender, and the owner is going to be that address, this contract. We have the price, and we have to set the sold status to false. Okay, then this is the initial data we'll assign when someone will create NFT. That's looking good. Let's see, let's close. We are done with this, done, and these all are looking good. Let's close this function, and this is the create token. Close this one as well, close this one as well, and now let's write other function as well. So let's come down and let me give this comment function for resale token. Okay, so this resell function will allow user to sell their NFT if they have the NFT, and if they want to resell in a higher price, so this function allow them to do that. So let's write the function for that. So we'll call it resell token, and in that we're going to pass the token ID. Okay, and we have to pass the updated price, whether he want to sell at a higher price or lower price. So he will pass the price, and now it become a public because so, and payable, so anybody can call this functions. And payable keyword is there because there is a transaction of money is happening. Okay, now we have to check for conditions. So here we'll check that ID market item, you have to pass the ID, token ID, and we have to check the owner, that who is the owner of that particular token, the ID he has provided, and we'll call it message.sender. Okay, so why we are getting this error? Okay, we have to remove this too. So now it's working fine. So here again we are calling this, and we are checking here. So what we are doing here, when someone will call this function, he or she has to pass these two data. First one is the token ID and the price. So on the base in the base of the token ID, we are mapping the data, and this all data is inside this ID market item. We are checking that who is the owner of that NFT, and the person is calling the function. If both the address get matched, then we want to continue further. Okay, and make the sell happen, resell happen, sorry. Let's come down, so that's the very first check. And here we have to pass the message, error message. Only item owner can perform this operation or purchase. Okay, let's come down. We have to do another checks, and in this we have to pass that ms dot value should be listing price. If it's less than that, then we have to pass this error message, because we have to make commissions whenever someone do any sale in our application. Okay, so that's the second check we are doing. Now we'll come here, we'll take this market item, we have the token ID, and we want to change the status. Sold status is going to be false, and we have to change the price to the price. Okay, and here we have to, let's say, change the payable to the message.sender, and here is going to be the seller, and here is going to be the owner. So this will become address this. So when someone will resell their NFT, the NFT will go to the contract, and contract become the owner. Okay, so that's the entire logic. We are not doing anything fancy, we are simply changing the entire state, the constructor we have defined. Okay, so that's the data. Let's come down, and now we have to call this item sold, and we have to decrease the count, because every time any sale will happen or anybody buy any NFT, this item sold count will go up. Okay, but when someone resell that, this number will go down. Okay, so that's will keep the track of it. Now we have to call this transfer function. So message.sender, and the will go to the contract address. So address this, and the token ID would be there. Okay, so this is the transfer function we are doing. So this is our resell token function. Okay, so everything's working fine. Now let's write the other function. So let me give this command. It called function create market item sale. So this function will allow to create sales. Okay, so function, and we'll call it create market sell. And in this we're going to take the unt, we have to take the token id because that's the unique to every nft, and we have to call it pay public payables, and we have to simply do couple of checks. So to create the sale, we're going to take the unt, and it will call price, and this nft price is available inside this id nft. We have to pass the token id dot price. So in this way we can able to get the price of that nft. Okay, we have the price which is coming from inside this here. Let's come down, and now let's working on our contract. So we come down and we have to do the check. So message dot sender, sorry, value should be equal to the price, and if it's not, then we have to display this error message. So please submit the asking price in order to complete the purchase. Okay, if someone wants to buy this nft, so they have to provide the exact price which is available in the nft for making the sale. Okay, so here we are checking for that. Let's come down. We have to take this nft item, and we have to pass this token id, and then we have to check for the owner. Owner is going to be the payable dot message dot sender. So whoever is calling the functions, he will become the owner once he make the payment. Okay, so that's, we are changing the state, owner state, and now we'll call this, pass this token id, and we'll say sold to true because nft gets solded. And now we have to simply say payable address 0. Okay, change this to owner. So right now this contract, this nft is not belong to the contract. So that's simple thing. I hope everything's making sense to all of you. Nothing fancy, very simple. We are just updating the data and transferring the token from one address to the another, and that's how we make sale. Now let's come down. We have to call this item sold. We have to increment that, and now we have to call this function. So this time address this, the contract address will send the token, because when someone will list the token, it will go to the contract itself, and when someone buy the token, it will, they have to buy from them. Okay, from the contract. So we'll send to message.sender, and we have to pass this token id. Then we have to call it payable honor dot transfer, and remove this one, and we have to get our commission. So we'll take the commissions like listing price. So whenever any sale will happen, we have to get our commissions, and this is going to be available in our owner address. Means I'm going to deploy the smart contract, so I become the owner of the marketplace, and whenever someone will sell the token, I'll get the money, the listing price which I have assigned, and the rest amount I'm going to send to the nft owner. Okay, and the data we have is there, pass that, and from here I will get the seller, so the owner of the nft, and then we have to call this transfer, and we'll transfer the message.value, so the exact nft value which he has assigned to for selling. Okay, so this is how we are making the sale. So this is our create market sale function. So everything's looking good. This is now let's come down, let's write the other functions for that. So let's come here, let me give this command, getting unsold nft data. So we want to display the data, all the nft from our smart contract. So let's write the function for that, and that's what we are doing. So I'll call it function and fetch market item. So all the nft we want to fetch. Okay, so it's going to be a public view return, and we're going to take a, let's say, market item, an array, and memory. Okay, so this is the array we're going to return. So let's come here. We're going to take a unt. First we call it item count, so we have to get the total items, and we're going to find it inside the total id dot current. So this will give that how many NFTs are there in our NFT marketplace. Okay, because every time someone will create NFT, this number will keep increasing. Okay, so I hope everything's making sense. Let's come down. Now we have to take another unt, and in this I will call unsold items. So those NFT which are not sold, so we have to keep the track of that. So what we'll do, we'll take this token dot current, and we're going to subtract this with number of token get sold. Okay, and we'll call it, here we have the data. Okay, this, and we call it dot current. So if I subtract the token ID with the total sold, I'll get that unsold item. Okay, so let's come here, and I call it current index. Initially it will become 0, and why it's happening like this? Okay, I have to format this. Let's bring it back. Now it's working fine. So here we have the current index, because we're going to loop over it. Okay, so we're going to loop over the entire NFT, and we're going to store inside this current index. Okay, so everything's will come make sense, so just walking along with me. So here I will take a, let's say, NFT market item array and memory, and I can call it item. So here I'm taking an array in which I'm going to store all the unsold NFT. Okay, so I'll call this new. I'll call it market item array, and here I have to provide the length, the number of array, the number of item I want to return. So this is how you have to do it. So new is a keyword available in Solidity, and that's what we are using. Okay, and here I have to provide the length, and this length I'm getting from the unsold item. Okay, so I want to fetch only those NFT which are not sell, so I can able to display on my front end application. Okay, so this is how we are creating that. Now we're going to loop over it. So I'll take it unt I is equal to 0. If I is less than item count, then I want to increment that. Okay, in this we're going to do a couple of things. So first I'll do the if statement. If market item I plus 1 dot honor equal to address this. So let me repeat once again what is happening here. So those NFT belong to this address smart contract. Address this is the smart contract. Those NFT is not sold. Okay, it's unsold NFT, and we want to get those NFT only. Okay, so that's the check we are doing. Why we're getting okay? Let's remove this one and bring this. So that's the check we are doing. If we find those NFT, we have to take this unt, and we'll call it current ID, and we're going to simply increment that I plus 1. Okay, every time this loop will happen, this current ID will increase. In that we'll pass this storage current, let's call it current items, and we're going to call this item, and in that we're going to pass this current ID. Okay, that's how we are keeping the track. Same thing we are doing what we have done above. So I hope things are getting clear. Now let's keep working. If you are still confused on anything, do leave in the comment section. I have a Discord team, so do join that Discord where we can able to answer your questions quickly, and a lot of members are already there. So if you have any common problems, and if they have already faced that, so they might can help you. Okay, so make sure you join our Discord server and write down your comment, so we can help you in that. So let's come here. I'll call it items, and in this we're going to pass the current index, and we're going to track it. So current item. Okay, and now we have to simply increment this index. So that's the thing we are doing, and finally we have to return the array items. Okay, so this is our fetch market item function, which allow us to get those NFT which are unsold, and this is how we are doing this check. Okay, we are trying to find out that what NFTs are belong to the contract. That means those NFTs are not sold, and try to fetch that. So that's the function for unsold NFT we have written. Okay, you can double check one more time. We are not getting any error. Okay, everything's look good. Now let's come down, let's write the other functions. So I'll call it purchase item. Okay, so I'll take a function. Let's call it fetch my NFT. So once you buy an NFT, we're going to display all the NFT which you have bought in your profile, in your NFT collection. So for that we are writing this function. Okay, so it's gonna be a public view return, and we have to return the array of NFT. Okay, because one user can have multiple NFT. Okay, so that's why we'll return the array. So market item memory, and here we're going to do things. Okay, first we'll take this unt. The same thing we have to do what we have done for fetching an unsold item. Okay, the same thing we have to follow here, same logic. So I'll call it total count. Initially it would be, let's say, number of token we have to find. So let's call it token id dot current. Then we have to take another unt, and in this we have to take this item count. Initially it would be 0. We'll take another unt, it will call current index, it could be 0. Okay, so we are taking this item count and total item count, and then we're going to solve this problem. Okay, then we will take a unt I is equal to 0. If I is less than total count, then we have to increment the I. Okay, so in this we're going to check id market I plus 1 dot owner equal to message dot sender. So here we are checking for that who is the owner, whether the owner is the message dot sender. Okay, that's the check we are doing. If it's that, then we have to update the data. So our item count plus 1, and we can come down, and here we're going to take the market item, because once we get the data, once we get this NFT belongs to this particular user, we have to store somewhere. Okay, and so we can render that, we can get that. Okay, so we'll call this market item memory items, and we call this new market item, and here we have to provide the length which is inside this item count. Okay, so all the NFT pal pass, and now we'll run for loop on this. So I is equal to 0. If I is less than total count, then we have to simply increment that I. Okay, and we have to simply take a variable called current id, and in that we have to increment this as well. We'll take a market items, and we'll say storage current items equal to id, and then we are going to pass this current id, same thing what we have done above. And then finally we're going to update the status. So items current index current item. Okay, and here we're going to call this current index plus 1. So updating the data, exactly the thing we have done above. Okay, so these are in this way we can able to get the complete data. Okay, I missed, so I have to wrap this entire thing in a if statement. So let's take a if statement, market item and I plus 1, then we have to check the owner equal to message dot sender, and then we have to write the entire code inside this, copy and paste here. Okay, so that's the simple change you have to do. Okay, in this way we can able to get the entire NFT belongs to a particular address, and once we done that, we have to return the entire NFT. So items. Okay, items. So that's the function for getting my NFT. Here we have the data if for statement, and now we are looping over it and returning the data. Let's come down and let's write the other function. So let's call it let me give this comment, single user item. Okay, so we want to also display the information about the NFT individually. Okay, so that's the logic we're going to write. Okay, so let's come here, we'll take this function and we'll call it fetch items listed, okay, public, view, return, and we want to return the market array, okay, memory. So provide this s, and now finally we have to return that. So before we run that, we have to take this unt, and I'll call it total count. Same thing we have to do here, okay. So this total count is available inside this id token id dot current. Now we'll take another unt, and it becomes items count 0, and we have to take another one, it will call current index 0. So these are the variables. Now let's come here, we'll take this, run a loop, I is equal to 0, I less than total count, and then we have to increment the I, so small I. And now we have to do a couple of checks. We'll take if market items I plus 1 belongs to the seller equal to message dot sender, okay, if the address of the seller and the person who's calling this function is equal, then we have to continue this function, and we'll say item count to 1 increment 1, okay. Now we'll come down and we'll take this another market array, market item array. It's gonna be a memory, we'll call it items, new market item, and that we have to pass this id and total count, total number of nft, okay. So that's the same convention we are following. Hope you guys are getting familiar. Let's continue. So in this we're going to run a for loop, unt I equal to 0, I is less than total count, then we have to increment the I, and we'll call it if I market items I plus 1 it belongs to the address as seller and message dot sender, then we want to simply take this unt 256 and current id, and we have to increment that as well. So we'll take this market item storage, call it current item, and we have to call this id market item current item, we have to pass in that. And now we have to get that items current id, current index, and equal to current id items. And once we have that, we have to increment the index, and simply we have to return that. So return items, same thing we have done in what we have done in the last three function, because we want to get a nft, okay. Same thing we are doing here for getting the nft. So you can see we have no more error, and let's have a look. So this is our fetch nft listed function, okay. We have written this, we have this function for loop. This is the market item array. Let's come up here, this is the fetch my nft functions, which allow us to give the nft belong to a particular address, and this is the fetch market items, which will return the unsold nft that belongs to the contract address, okay. In this we are looping over it, and this is the create market sale, okay. So when someone want to buy nft, this function will get triggered, and it will update the status and the data and transfer of money, okay. So here we are doing all the things, and now we have this resale. So if someone have bought it and they want to resell, this function will get triggered, and here we are changing the state and from sender to the contract. And here we have the create token, so this function will create the unit id for every nft, okay. And here we have this get listing price function. So let's open this one, this is the get listing price function, and here we have this update listing price, and this is our constructor, this is our modifier, this is our event, and this is the struct and mapping, and this is the state variable we have defined in the smart contract. So with this we are done with our complete NFT Marketplace smart contract, and right now we can't test it because we haven't built the front-end application. Okay, so in this video we have completed the entire smart contract for our NFT marketplace. In the next video, we're going to build the front end applications, and once we build the complete front end application, we're going to integrate this NFT marketplace smart contract with our front end application, and then we can do the testing and we'll create NFT and list in our marketplace. So once we'll do that, so we have built this NFT marketplace, we will build the entire front end. So we'll do the testing with the smart contract, and once we're done with the entire thing, then we're going to build the backend part. Okay, so I believe that whatever we have covered in this complete NFT market project, smart contract development project, everything is making sense. I'll try to explain as simple as it, so you guys can understand that what are the things goes into this when you want to create your own NFT marketplace or any type of contract. So just imagine that if I want to write this from scratch without using any external packages which we are used in this project like OpenZepplin, if I have to create the same functionality, I have to write thousands of code and a lot of files. So it's always good, you should always try to find the latest tools which is available in the market. Okay, so anybody can create code. Okay, writing code is not the big deal, but you have to know that what codes are already exist, what are the best practices are already follow in the industry for that particular project which you want to build. Okay, in that way you can able to save a lot of time, you can able to build faster project, and you will have the security. Because if I build the same project from scratch by my own, who will be there to do the security testing? Okay, because that's the most important part of the smart contract. This contract will keep like lot of NFTs, and those NFT will cost $1 billion or $1 million depend on the type of project you are working on. So if that NFT get highly valuated, then you have to be secure that your smart contract is non-hackable. No one can hack it and no one can take those NFT. So that's the thing you have to keep in mind. Okay, you should always review a smart contract. Never sit down once you build your smart contract. It's a continuously evaluation you have to do throughout the entire process. Right now you have built the smart contract, every time you have to test, and that's why I have used OpenZepplin, because it's already tested, well tested for minting functions, for transfer function. These are already well tested. So that's what we have used. Okay, so I hope everything is making sense to you. Again, I'm telling you, the final code is already provided to you, all of you, on my website. You can go, you can get the starter file, you can get the complete file, you can get all the assets which we have used in this project. And if you're stuck anywhere, or if you find that nothing is working, something's wrong in the code, you can simply copy the code and compare your code. I would not tell you to simply copy the entire code and use as it is. Okay, in that way you will not learn anything. Okay, that becomes simply copy paste. So just write along with me. If you're stuck, compare the codes, and that's only, I provided this code only for comparison purpose. Okay, only for comparing. If you're stuck anywhere, you can compare, because I do understand that when you build write application like this, you will commit some sort of mistakes, you will find some sort of error, and my code would be different from yours in certain positions. So in those scenario, if you get an error, you can compare, but don't simply copy and paste, because that will teach you nothing. Okay, that will teach you nothing. When you start building from fresh, you will find that you know nothing. Okay, so all these assets, all the codes are provided just for test, but just for comparison purpose. Okay, so that's the only thing I wanted to cover. Again, I'm telling you, we have finally completed the entire smart contract for our NFT marketplace. In the next video, we're going to build our front end applications. So from the next video, we're going to build our front end application. Okay, we have built the smart contract. From the next, we're going to build the front end applications, and that part I have divided in couple of more parts, because you can see that our NFT marketplace is really huge. We have to build 16 plus pages. We have to build home, seller, authors, a lot of pages we have to build. So each of the things are very complicated, because it's an NFT marketplace. We have to build a lot of things. So I have divided the entire project into a small component. So one time we are dealing with the navigation bar, hero sections, slider, okay, the fetching data. And so you can understand that how we are passing the states, how we are passing the component. Okay, and I'm going to create some demo data, and from there we're going to do the rendering. So when we actually fetch the data from our API, we don't have any trouble. All you have to do is to simply plug this API information, and the entire rendering process will happen. Okay, so you will find a lot of things in that. So right now you will find that there is a lot of things, but exactly there is a lot of things. and there is a lot of learning for you. Okay, so with this, I hope you have enjoyed this NFT smart contract project, and in the next video we'll start working on our templates. So hope to see you there, and I hope you are enjoying this complete project. Okay, so that's the only thing I want to share. If you are new to my channel, hit like and subscribe. That will motivate me a lot to build this project, and it took really a lot of effort me to come up with this project. It took me around a month to build this project, and if you build this project, we are building a lot of things: smart contract, front end, and the back end. It will take around 15 to 20 hours to build this complete project. So hope you will enjoy it, and this is a huge course, so I want you to enjoy and take rest. So take rest and then continue with the project. So that's it. Have a wonderful day. See you in the next video.